But we have a boat that normally travels in still water at 20 miles per hour. We have a current of 5 miles per hour. And we've got our boat trying to go straight across a river. So here's our boat. We're trying to go straight across, but the current is going to take us downstream. So the boat's going 20 miles per hour up, trying to. The boat's trying to make us go down. So, I mean, you can see what's going to happen. We're going to go like this. We're going to end up going across the river. We need to figure out the net speed and direction of the boat. So we write both of these as vectors. So let's say our boat vector, let's call it vector B, tries to go straight up, and our current vector, we'll call it vector C, tries to go straight to the right, according to the picture I've drawn. Okay, my vector B is the vector. It's trying to go straight up in the y direction, so it wants to be 0, 20 in miles per hour. And my current vector wants to point straight along the x-axis. It has an x component of 5 and a y component of 0, again in miles per hour. So adding these vectors is easy. So our net velocity vector, our F net, let's not call it F, our net or resultant vector, V, will be add these as vectors, which means add the components. So 0 plus 5 is 5. 20 plus 0 is 20. So that will be a vector. 2, 3, 4, 5, 1, 2, 3, 4, 5. Be a vector that points like that. Okay, let's find the magnitude of that vector, which will be the speed. Magnitude of velocity is speed. That's a scalar. So our speed is the magnitude of our velocity vector, square root of 5 squared plus 20 squared. So that's square root of 425. Let's type that in our calculator. I don't need to pull it up. 20.62 miles per hour. Don't forget your units. So there's the speed of the boat. Now let's find the direction. So again, we have this vector here. Here's my net vector, 520. The x component is 5. The y component is 20. Let's find that angle right there. Forget about formulas. Don't memorize formulas. Just use your trig that you know. So I could just say, looking at the picture, tangent of theta will be 20 over 5. So that angle right there, whatever that is, will be inverse tangent of 20 over 5. Okay, so I'll throw that in my calculator. 75.96 degrees. Now I can't just leave it like that. Direction is always relative to something in the problem. I can't say from the x-axis. The problem didn't even mention an x-axis. As far as I know, my boat may not even be going north, south, east, or west. It may be going at some weird angle. So if I'm going to use what I was given in the problem, the only thing I know is the direction of the current. That's downriver. This direction is downstream. The direction the current's flowing. So I know my boat is going to be going 75 degrees from downstream. Because here's downstream, my angle, that's this way, is this way. That right there is my 75 degree angle. So 75 degrees from the direction of downstream.